Okay, so in this second part of our sum and difference of angle identities, you're given a different kind of problem where you need to find the tangent of a plus b, or maybe cosine of a minus b, given a couple of different angles. So in this case, they tell us the angles are both in quadrant 1, and that we know that tangent of a is 7 over 24 and tangent of b is 15 over 8. And that we need to find tangent of a plus b. So what I would suggest with these is to draw yourself a couple of pictures first. So looking at what does a look like. So we're in quadrant 1, we know that. And again, it doesn't have to be a great picture. Mine certainly is not. But you just want some type of reference and try to make it accurate, at least in terms of what quadrant it's in. Okay, so tangent opposite over adjacent, and we know that it's 7 over 24. Now, you may or may not need the hypotenuse sometimes, but I always like to find it anyways. So you're just going to do a squared plus b squared equals c squared and do a little solving. In this case, you should end up with your hypotenuse being 25. Okay, so now let's go and let's do b. So b is also in quadrant 1. And this time it's 15 over 8, so opposite is 15. Adjacent is 8. So again, do a little figuring to try to find your hypotenuse. 8 squared plus 15 squared equals c squared. Take the square root, you should get 17. Okay, so again, you won't always need the hypotenuse there, but it's just helpful to have it because a lot of times you do. So now I have a plus b, so I'm going to use this formula right here. So I'm just going to write that out. So I have tangent of a plus tangent of b over 1 minus tangent of a times tangent of b. All right, so we get tangent of a, we already know, is 7 over 24, plus tangent of b is 15 over 8. And then I have 1 minus tangent of a, which is 7 over 24, times tangent of b, which is 15 over 8. Okay. So now when you figure this out, again, the top here, you need a common denominator if you're going to simplify the top. So you could multiply the top and the bottom by 3 for the second one. You could use your calculator and reduce it. Make sure your answer is reduced. But either way, however you get there, you should end up with 13 over 6 for your numerator. And again, use your calculator, or do it by hand, however you want, and then make sure it's reduced. So here on the bottom, we have 1 minus, and then you're going to multiply those two things and then reduce. So when you multiply 7 24ths times 15 eighths, get your answer and then reduce it. You guys can all do this, so I'm not going to go through that. So we end up with this, all right? 35 over 64. So now I really want to simplify this bottom here before I move on and do any multiplying and whatnot. So remember, this right here is really 64 over 64. Okay, so I'm going to go over here on the left, erase this here, and just finish this up. Okay, so on the top I would have 13 over 6 On the bottom, I would have 64 64ths minus 35. 64ths would give me 29 64ths. Okay, you're going to multiply by the reciprocal. Okay, that's going to give me a pretty big number. 832 over 174. And then we need to reduce that. So just, again, use your calculator to do the math, frickin' fracs thing to reduce it if you need to. You should end up with 416 over 87. Okay. So that's our answer for that one. Really, the pre-calculus stuff is this just the beginning of this. The rest of this is just a lot of dealing with fractions, adding, multiplying, dividing. It's my dog shaking. I don't know if you could hear that or not. But okay, so that's one problem. Let's go over another one to make sure we understand this. It's got a little bit of different stuff going on. In this time, we are given angle A in quadrant 1. And sine of A is 12 over 13. And angle B is in quadrant 2 this time. And sine of B is 4/5. And we need to find cosine of A minus B. So once again, with this, I would suggest you draw a picture for yourself. So A, quadrant 1, so it's going to be something like this. And then sine, opposite over hypotenuse. So I should have 12/13. And then, again, do a little math for this. You should end up with, using Pythagorean theorem, you should end up with 5. And you will need that this time for sure. So, again, it's always beneficial, I think, to just kind of find all three sides. All right, so now the other one, B, this angle is in quadrant 2, so it's going to look more like this. Okay. And we are given sine of B is 4/5. So opposite over hypotenuse. And then you're going to do a squared plus 4 squared equals 5 squared. Solve that. You should end up with 3 here. And you will also need that when you figure these out. So now we're trying to find cosine of A minus B. So that's this formula right here that we will need. So I'm going to write that out. Here we go. We've got cosine of A times cosine of B plus sine of A times sine of B. Okay. So now cosine of A and cosine of B we are not given. We are given sine of A and sine of B. So that's where you have to use your two triangles here to figure out those values. So the cosine of A, we're going to look at A cosine from this would be adjacent over hypotenuse. So that should be 5 over 13. Okay, and then we want to do the cosine of B now. And again, adjacent over hypotenuse should be 3/5. One thing that I forgot to do here, and this should be negative because we're in quadrant 2. So I want to make sure I put that on there. And that's an important piece, and it's easy to forget. So make sure when you're drawing in different quadrants, you put the negatives on there. Okay, so we've got that now. And then now I want to come over here and do sine of A. So sine of A we know. That was given to us. You can confirm it on your triangle if you have to. And then sine of B we're also given. Okay, so you're going to multiply these two. You get negative 15 over 65. You probably don't want to simplify these because the denominators are going to be the same this way. So then you won't have to do more fixing. So I'll have 65 on the bottom of both of these. And since I have to add them, I'm going to leave it. Of course, 15 over 65 can be reduced, but like you'll see here in a second. Now I've got two denominators, both 65, and that'll make it easier. So now I'm going to put these together. add, I need a common denominator. I have that already, so yay. And then negative 15 plus 48 is 33. You want to try to reduce it. You won't be able to, so that one's it. And now those are other different types of problems using the sum and difference of angle identities. Again, the key with these is drawing your angles, and be wary of those negatives when you're drawing your triangles for different quadrants. Okay? I hope that makes sense. Again, feel free to text me so we can set up a meet or something like that if you're struggling, or if you just want to go back and forth. All right. Have a good one. See ya.